Okay, so the next thing we're going to talk about are reflections. So a reflection is simply, well, reflecting or taking a mirror image over a specified line of an object. So a reflection would mean that we're transforming something by taking an object like triangle ABC, our favorite triangle, and we'd be reflecting it over a specific line, what's called a line of reflection. Now the line of reflection, we'll call that L, right, can be anywhere, okay? That is, it could be here, it could be here, it could be in the shape itself. But whatever it means by definition, when we do the reflection, it's going to take each point and it's going to take the perpendicular distance of each point. So that would be the perpendicular distance. So the perpendicular, that is, you draw a perpendicular, that's a 90-degree angle. Distance, you figure out what that distance is to that point, and then it's going to cause it to be then reflected. So that is, we're going to be reflecting it. So I can bear with me here a sec, means that the new location of, in this case, C prime, is going to be the same distance, but on the opposite side of the line of reflection. So what this means in this particular case would mean that C prime would be right here. And what then this means that the shape will be on the other side of the line of reflection. So then A prime would be approximately here, and here I'm just kind of approximating. Then, B prime's about that far, so that's about that far. And so we end up with a reflection, meaning that the shape has been transformed over the line such that the perpendicular distance of each of the points, in this case the vertices, but also any point here, so the distance from here to here and here to here are going to be the same, but on the opposite side. Does it preserve orientation? Well, the orientation here would be ABC, and the orientation here would be AC, A prime, C prime, B prime. So no, it does not preserve orientation. It's one of the few ones that does not. Is it rigid? Well, the only thing we're doing is moving this. So yes, it is rigid, aka they are in isometry. Now, this may seem irrelevant, but it's not, because we need to talk about the equations for vertical lines, which are lines that look like this, right? And those are generally of the form x equals a number, like 2 or 3 or 5 or whatever. The x values are always the same. Conversely, a horizontal line, as a little reminder, y equals a number. That is a constant. There's no slope. It's a zero slope. In this case, it has undefined slope, but here y equals a number. The equation for the x-axis, you're going to need to know this. The equation for the x-axis is going to be y equals 0, because if you think about the x-axis, it is a horizontal line, right? And has it been moved up or down? No. The equation for the y-axis, right, is a vertical line, so it's going to be x equals, and where is it? Well, has it been moved left or right? So it's x equals 0. There are two other lines that I haven't mentioned, and that's y equals x and y equals opposite x. So y equals x. Both of these have a y-intercept of 0. In this case, this has a slope of 1, so y equals x would be, let me just get this going correctly here, y equals x would be going up 1 and over 1. So that means, for instance, 2, 2 would be a point on the line y equals x, okay? And so y equals x is this line. It's at a 45-degree angle, right? Think about it, it's splitting this evenly, right? Now, y equals opposite x is the same sort of idea, but it's got a -1 slope, so it still has a y-intercept of 0, but it's got a -1 slope, which means points like -2, +2 are on here, or in this case it'd be like maybe the point 3, -3, right? Still a 45-degree angle here and here, right? But that's what the line y equals opposite x would look like. Now, reflection notation. You reflect, and that's lowercase r, and then you write the equation of the line you're reflecting over it. So like if you're reflecting over the line y equals 0, then that's also known as the what? Y equals 0. That would be the x-axis. This is like reflecting over the x-axis on the point xy would become whatever it becomes. Or you could reflect over the line x equals 4, and like we just talked about, x equals 4 would be a vertical line that we're reflecting those particular points over. So there are some reflections that you're going to need to memorize the formulas for. And those in particular are reflecting over the x-axis, the y-axis, y equals x, and y equals opposite x. So here are the formulas. For y equals 0, which is also known as the x-axis, we know that when we reflect over the x-axis, it's going to be x and then opposite y. So for instance, if we reflect over the line y equals 0, the point 2, 4, the x value will stay the same, so it'll be 2, and the y value become the opposite. For the y-axis on xy, the general form is that the y will stay the same, but the x will become the opposite sign. So if I were to do a reflection over x equals 0, aka the y-axis, then 3, negative 5 will become, well, 3 becomes opposite 3, right? Negative 5. We'll look at some examples here too. Reflection over the line y equals x. So what they're saying is the y is equal to the x and vice versa. So what this means is whatever our original x is becomes our y, and whatever our original y is becomes our x because they're equal. So if I reflect over the line y equals x, negative 3, 5, that becomes 5, negative 3. They just change places. Last but certainly not least, if I reflect over the line y equals opposite x, then y becomes x, but they also become the opposite sign. Meaning, now these negatives here are actually not making them negative, they are making them the opposite. So when I do a reflection over y equals opposite x of say 2, negative 6, then I know that they're going to flip places, so it's going to become negative 6, 2, but they're also going to change signs. So that's what these negatives really mean. It means you're changing signs. So this would become positive 6 and then a negative 2. Notice opposite of negative, positive, opposite of positive, negative. All right. So let's take a look at some examples of what this looks like in a more graphical sense. So I'm going to go ahead and choose this as a line of reflection. This is the x-axis, and I'm going to reflect this. I'm going to try to reflect this. There we go. And apply it. So what has it done? I reflected over the x-axis, and indeed, if you look at this, so this is, remember, this is our x-axis here. X-axis. X-axis, then what happened is this distance here is the same but on the other side. And that is why when we reflect over the x-axis, aka the line y equals 0, the original points, pre-image, are going to become, well, have these moved left or right? No. So the x is going to stay the same, but look, the y has become the opposite. Now, what if this were my original and I reflected it? Well, I'd end up here, right? So this would be my b and this would be my b prime. So what was negative became positive, in other words, the opposite. Okay. What if I were to go ahead and boldly cancel that out and do a reflection over the y-axis? So now I'm reflecting over the y-axis. This point, this shape. Well, we would anticipate that it would jump on the other side of this and be the same distance. So this is 1, 2, 3, 4, 5 away. 1, 2, 3, 4. We would expect that the new shape, 1, 2, 3, 4, 5, would be 5 units on the other side. I'm going to count carefully here. 5, just like that. And that would be where A prime is. B prime is farther away. In fact, it's 2 farther away, so we'd expect B prime to be there, and C prime being in the middle of it. So we wouldn't expect it to move up or down. Sorry, that's C prime. So let's see. Is this then what we hoped for? So let me go ahead and do this. So reflection over this line, this object. Look at that. It's perfect prediction. So what does that mean? It means that when we reflect over the line, and this is what gets people, x equals 0, which is also known as the y-axis, xy. The y stays the same, but the x becomes the opposite sign. Okay? Let's try a couple of more. Let's draw a line here. So now I'm going to go ahead and I'm going to do a reflection. I'm going to have to construct a line. So let's construct a line that represents the y equals x. So look, up 1 over 1, that would be the line y equals x. So now what I'm going to do is reflect over that line, specifically this line, this object, and apply it. So that you go on the other side, same distance. So if you look, that's diagonally 1 unit, and we'd expect it to be up there. Now actually, one thing I'm going to do, I'm going to show you something. What happens when you move an object around? In other words, what if I were to move this so that it was down here? Well, obviously its image is going to be over on the other side, right? What if I move it closer? That would mean that all the points, that it gets closer to that line, because the distance between these has to be the same. What if I stretch the thing? So what if I make it like that? Well, so then the distance is preserved. Now I'm going to try to keep these on specific coordinates to make this easier on myself, because that way when I'm looking at this, I know, for instance, that this is the point 1, 2, 3, 4, -1. That would be C. So C prime should be -1, 4, or back 1, up 4, so this should be C prime, and sure enough, it is. So remember, it's pretty simple when you're reflecting over the line y equals x, in that the x's and the y's just change spots. Okay? Last one would be the line y equals opposite x. So what I'm going to do is I'm going to move this around a little bit. I'm going to take and move this point so it doesn't get too cluttered. So now we're talking down 1 over 1. So now when I transform or reflect over this line, which is the y opposite x, it goes on the other side there, right? So please bear in mind, like we've talked about, let's pick this color right there, okay? We know that the orientation, so C, this must be C prime. A, this must be A prime. Look, smallest angle, smallest, or actually that's the smallest angle, that'd be B prime, smallest angle, largest angle, next largest. So this would be all those points. So C, which we knew to be 4, -1, has become what? Well, they've exchanged places and became the opposite sign. So C prime should be +1, -4, and sure enough, over 1, down 4, right? And that is how we reflect over the line y equals opposite x.